Hello students, welcome back. Let's go to problem 4. This time, let's study two-sample inference. Here's a problem, and please stop the playback and read through the problem all the way to the end. A random sample of 18 homes south of Center Street in Provo has a mean selling price of $144,950 and a standard deviation of $4,500. And a random sample of 13 homes north of Center Street has a mean selling price of $148,650 and a standard deviation of $5,750. Assume that the home prices are normally distributed. Okay, by the way, this problem was taken from one of the textbook, and therefore this probably is based upon old data. As for home prices, these are a bit too low in today's standard. And also, home prices are not usually normally distributed. Therefore, typically we use medians instead of means, but for the sake of a mathematics exercise, let's assume the home prices are normally distributed and let us accept these mean selling prices. Okay, alright, let's go to 4.1. Which approximation is more appropriate, Z or T? Clearly, this is a T-curve problem. 18 homes, 13 homes. Small sample size. They're both less than 50. Actually, they're even less than 30. Now, as for standard deviations here, they are both coming from sample. A random sample of 18 homes, and then the mean and standard deviation. You see, this is sample standard deviation. A random sample of 13 homes, and the mean and the standard deviation. They are both sample standard deviation. As for population standard deviation, no information. So we have to use T-curve, T-approximation. Okay, let's go to the next problem. Let's go to 95% confidence interval. Here's a hint, by the way. Use the degree of freedom of 22 and standard error of this number. And we have some magic formula here that presents this degree of freedom. And I'm not going to talk about why. In the end, degree of freedom turns out to be 22. Okay, that saves us time, so let's use it. Standard error, on the other hand, is pretty typical actually. Standard error of first sample squared, standard error of the second sample squared. You see, S over square root of n for first sample and second sample. And then square root, so it's kind of Pythagorean. Okay, let's use these, and here we go. Here's the initial picture. Let mu be the difference of the means. Let x bar be the difference of the sample means. And then real mu, where is it? Well, the difference of sample is 3,700. Let's see. 148,650 minus 144,950. 3,700. That's the observed difference in mean. And then we want to find out the starting point and the ending point of the interval. Okay, how do you find it? Well, this is T problem, so let's go from the right. End minus center over SE is going to be the T statistic. And the T statistic that we want for 2.5% here, by the way, we just discussed it. For 2.5% there, you're going to get 2.074. Let's see, is that it? Let's see, 2.5%. We want here, this point is 2.5%. So 2.5% here, 0.025 for degree of freedom of 22. Yes, 2.074. 2.074 So let's solve this equation, and that's about it. Flip this denominator to the other side so that we have this product. And then 3,700, flip it over, then we have this computation. And that led up to 7,672. How about the other endpoint? Yes, from here, we went to the right by adding. So from here, we'll subtract the same thing. Just use symmetry. This plus becomes minus, and there goes the other endpoint. Negative 272 to 7,672. And here is the conclusion, the confidence interval. From here to there. Okay, please note that 0 falls somewhere here, the difference 0. So difference 0 is pretty close to 3,700 according to all this. Alright, we are done with the interval estimation, so let's go to hypothesis testing. Does this sample study suggest that the houses north of Center Street more expensive on the average? So 148,650 versus 144,950 using these standard deviations. Well, let's start the hypotheses. The null is always no difference, unless the problem explicitly gives you the difference is greater than something like that. So no difference. And then alternative, well, north is more expensive, so the difference is positive. Okay, here is the critical value method. So here's the initial picture. And then centered around 0, the null hypothesis is 0, so centered around 0. And then 3,700, that's to the right. And then we are also looking for mu is greater than 0, so to the right. You get something like this. So here's a critical value, and then where is the 3,700 falling? Here, close enough to null. There, too far away from the null. So too far away, null loses. Close enough to null, null wins. Okay, let's calculate. N minus center over SC. So here we go. N minus center over SC is equal to the t statistics associated to 5%. Let's see. This is 5%, so 5% here, and then go down to degree of freedom of 22, 1.717. That's how I got this 1.717. See, t-table here. Degree of freedom is 22, 1.717 here. That came from 5%. Okay, flip this denominator over and do your computation. You get 3,288, 3,300 approximately speaking, and compare that with 3,700. Here's the picture. 3,300, 3,700. 3,700 is bigger, so it's farther away from the null. So, too far away from the null, null loses. We accept alternative hypothesis. Okay. Once you find the critical value, it's easy. Too far away, null loses. Close enough, null wins. Okay, that was critical value approach. Students usually do best this way. And here's probability value approach. Here's the initial picture. Here's null, and then 3,700. And we want to find out this probability by calculating the t-score and using statistical calculator. N minus center over SE is just straightforward computation, and then use statistical calculator to find out the probability when t is greater than that. Assuming you did it, you get 0.033. Now the hard part. What does that mean? What does that mean? That means the probability that the conditional probability, while null is right, but the t is so great, so by some rotten luck, the observed the mean difference is so large, larger than 3,700, or at least 3,700, is 0.033 is that probability. So that probability is pretty low. So by rotten luck, you're going to get something like this. That probability is relatively low. So we're going to accept the null hypothesis. So that's the idea behind type 1 error and null versus alternative. Were you able to follow all that? If you do, great. But otherwise, don't use this unless you know what you're doing. Students who choose the probability value method, p-value method, usually do worst. Hybrid method, both of them together. Here is the initial picture. We have standard t-curve from 0, and then this is t-statistics. Okay, not 3,700 or actual critical value, but critical t-statistic associated to 5%. So here we go, 1.717. Now, as for 3,700, the observed difference, where is it? The difference between the two. We have to calculate the t-statistic for that, and we get 1.93. What do you mean by that? This t-value, those are processed values, kind of rescaling. So t is big, so that observed mean will fall here in red region, farther away than this threshold t-statistic, so alternative wins. Null loses, too far away from null. But that argument is a little bit tricky to handle because you don't have null right here and you don't have critical value right here, and you are not using 3,700 right away. A little bit hard to understand, but still, it's okay. Especially compared with p-value approach, it's better. Finally, how about confidence interval method? Well, do you recall confidence interval computation? Calculate the confidence interval, and we got this, 3,700 was here, but 0 was inside the confidence interval, so that means 0 must be close to 3,700, but why? Why is null hypothesis losing? Well, that's because that confidence interval was 95 confidence interval with 2 bounds. For this kind of testing, you have to have one-sided confidence interval. That is, in this case, just lower confidence bound, like this. You see? You don't want 25% here, 2.5% here. You want 5% there. So if you take this confidence interval from 3,700 and work it out, negative 1.717, and we get 411. So 0 does not belong to that confidence interval. What's with this picture? Let me try to fix it. Okay, there you go. 3,700 and then 410. Not negative 270 something. 410, and 0 falls here outside the confidence interval. That's why null loses.